Hello everyone and welcome back to our explainer series on software engineering. Today, we're zooming in on a really crucial topic from chapter 6 of your textbook, architectural views. I'm actually super excited to walk you through this material because understanding how to properly design and, just as importantly, communicate a system's architecture, well, that is the critical missing link between just hacking together some code and actually engineering robust, large-scale software. We're going to take this step by step, breaking down every single concept as if you're seeing it for the very first time. So grab your notebooks, get comfortable, and let's get into it.
Here is our agenda for this session. We'll start with why multiple views actually matter, then move into Kruchten's famous 4+1 model. After that, we'll look at adding the conceptual view, tackle the UML notation debate, explore Agile and architectural documentation, and wrap it all up with a summary and some high-yield exam focus.
All right, Section 1. Why multiple views matter and the sheer necessity of different perspectives. So, the absolute core concept you need to wrap your head around here is that when you are designing a complex software system, a single perspective is just never, ever enough. We have to look at the system from different angles, depending on exactly who is asking the questions. To really frame this, I want to pose a question directly to you. Can one single diagram explain an entire complex software system? I mean, really think about that for a second. If you were building a massive global banking application, could one drawing possibly show the databases, the servers, the code structure, and the user interface all at once without turning into a completely unreadable tangled mess? The answer, of course, is absolutely no way.
It's kind of like building a house. You can't just hand one single piece of paper to your entire construction crew and say, "Go." You need a floor plan to show the walls and the rooms. But the plumber? They need a highly specific plumbing diagram showing pipes and water flow. The electrician needs an electrical schematic showing wires and outlets. If you tried to mash all of that onto one single drawing, nobody would be able to read it. Building software is exactly the same thing. We need multiple architectural views because different stakeholders, like your programmers, your systems engineers, your project managers, they all need to see totally different blueprints of that exact same system. So the big takeaway here? Complex software, just like a building, requires different visual blueprints to communicate effectively with different people.
Moving on to Section 2, Kruchten's 4+1 model. This is our fundamental academic framework. Okay, this right here is the real academic meat of our explainer today, so please take careful notes. To solve this exact problem of needing multiple blueprints, a researcher named Philippe Kruchten proposed a specific model back in 1995, and it has pretty much become a gold standard in software engineering. Take a look at this figure directly from your textbook. You'll see that central box representing the overall system architecture, and it's surrounded by 4 distinct perspectives represented by those eye icons. We've got the logical view, the process view, the physical view, and the development view. Let's break down exactly what each of these actually means, one by one.
First up, we have the logical view. Now, by key abstractions, we basically mean the main conceptual objects or object classes that make up the system. Think of this as the real-world entities the system deals with. For example, if you're building a hospital system, your logical view would show objects like patient, doctor, and consultation. This view is absolutely crucial because it maps directly to your functional system requirements. It essentially shows what the system is logically supposed to do. Next is the process view. This view shows how the system operates when it is actually running, at runtime. It shows the interacting processes and threads. And why do we need this? Well, because it helps us make vital judgments about non-functional requirements. Remember, a non-functional requirement is a specification of how well a system does something, not just what it does. So the process view helps us check critical things like performance, speed, and availability, ensuring your whole system doesn't just crash the second 1,000 users log in at once.
Then we've got the development view. This one shows how the software is broken down, or decomposed, into specific components, modules, or packages. This view is tailor-made specifically for the software development teams and their managers. It directly answers the question, how on earth do we divide this massive project into smaller, manageable pieces so that different programmers can write the code without constantly getting in each other's way?
Finally, the physical view. I want you to listen closely here because a really common mistake students make is thinking that this view is about physical code files. Actually, scratch that. It is not about code files at all. The physical view is strictly about the hardware. It shows the system's actual hardware layout, the physical servers, processors, and networks, and how the software components are distributed across them. This view is strictly for your systems engineers who are planning the actual deployment of the software out into the real world.
So, we have these 4 very different views, but how do we prove they all describe the exact same system? That, my friends, is where the +1 comes in. The +1 refers to common use cases or user scenarios. Remember, a use case is simply a description of how a user interacts with the system to achieve a specific goal. These scenarios act like a central thread that ties all 4 of those separate views together. They basically prove that the logical objects, the runtime processes, the developer components, and the physical hardware all actually work together to achieve the user's ultimate goal. To quickly recap, the 4+1 model uses logical, process, development, and physical views, and they are all tied perfectly together by use case scenarios.
Section 3. Adding the conceptual view. Expanding this model for our non-technical stakeholders.
So while Kruchten's model is undoubtedly fantastic, other researchers, specifically someone named Hofmeister, suggested we need to expand it just a bit to help conceptualize the system for people who don't write code. This expansion is known as the conceptual view. This is a highly abstract view of the system used very early on, and when I say abstract, that just means it deliberately hides all the complex technical details. The primary, absolute main goal of the conceptual view is high-level communication. It's used right at the start of a project to explain the architecture to non-technical stakeholders. Think business owners, clients, or investors who just need to understand the big picture without getting bogged down in the tech.
Let's walk through the benefits step by step. Because it is highly abstract, it easily explains the system to those non-technical folks. It helps decompose or break down very high-level requirements early in the design process, way before anyone writes a single line of code. To connect this to a previous lesson, think back to that block diagram of the packing robot system from earlier in this chapter. Remember? It just showed simple boxes for the vision component and the packaging component. It didn't show the underlying code or the exact hardware specs, it just conceptually explained how the robot worked. That is a perfect example of a conceptual view. So just to recap, the conceptual view is your high-level, abstract approach used early on to talk to business stakeholders before getting into the technical weeds.
Section 4. The UML notation debate. How should we actually draw our architectures?
Okay, so now we know what views we need, but how should we actually go about drawing them in practice? Well, here we actually have a bit of a lively debate in the software engineering community. On one side, we have UML, which stands for Unified Modeling Language. UML is a highly standardized, rigorous way of drawing software diagrams. However, Ian Sommerville, the author of your textbook, has a slightly controversial take here. He argues that UML, while totally great for detailed object-oriented programming later on in the process, is actually way too detailed and far too specialized for early architectural design. On the other side of the debate, we have informal block diagrams. Sommerville argues that for high-level architecture, informal block diagrams drawn quickly on a whiteboard are much, much better. Why? Because they aren't cluttered with unnecessary rules and details, making them incredibly excellent for high-level team communication. In short, save your complex UML for later and use quick, easy block diagrams for that early team communication.
Let's look at Section 5, Agile and Architectural Documentation, and finding the right balance.
Let's see how all this theory actually builds into real-world practice. How do modern Agile development teams handle all these multiple architectural views and the mountain of documentation that comes with them? Well, the Agile perspective on architecture strongly favors creating only the architectural views that are actually needed for effective communication. Historically, folks tried using these highly complex tools called ADLs, or architectural description languages. I want to briefly mention ADLs here, but honestly, we can pretty much dismiss them. They are generally far too specialized for mainstream use today. Agile teaches us that creating massive, exhaustive, detailed architectural documents for every single perspective using highly specialized languages is, frankly, a massive waste of time.
To really highlight this, take a look at this quote directly from your text. Users of Agile methods claim that detailed design documentation is mostly unused. It is therefore a waste of time and money to develop these documents, except for critical systems. The absolute key takeaway here is balance. Unless you are building a life-or-death critical system, like, say, flight control software for an airplane or a pacemaker, you should really only draw the architectural views that are genuinely useful for your team at that specific moment. To recap the Agile perspective, balance is key. Skip the exhaustive, specialized documents and only draw what your team actually needs to communicate. Unless, of course, human lives depend on the system.
Finally, Section 6, Summary and Exam Focus. These are the high-yield facts for your test. Okay, everyone, listen up because I want your full, undivided attention here. These are the high-yield facts that will absolutely most likely appear on your upcoming program exams. You must be able to list and define all 4 views of Kruchten's model. Let's recap them one last time together. Number 1, the logical view. Its purpose is to show key abstractions and map functional requirements. The target stakeholders, your system architects. Number 2, the process view. Its purpose is to show runtime behavior to check performance and availability. Target stakeholders, your performance engineers. Number 3, the development view. Its purpose is the software breakdown for actual coding. Target stakeholders, the programmers themselves. And number 4, the physical view. Its purpose is hardware and processor distribution. Target stakeholders, the systems engineers. Please, for your own sake, make sure you memorize this exact breakdown before we move on to the next topic in the program.
To completely wrap up today's explainer, I want to leave you with this final, really important thought. While we have all these fascinating academic models and debates about notation, always remember this. The best architectural view is simply the one that answers the specific question the team is asking at that very moment. At the end of the day, software architecture is about clear, effective communication first and foremost. As we move into our next topic on specific architectural patterns, things like client-server and model view controller, I want you to constantly keep asking yourself, who needs to see this and what exact question are we trying to answer? Thank you so much for joining me for this lecture session and happy studying!